Okay, let me get this started. We're going to talk about circles, uh, angles, arcs, and chords. Okay. Um, to start with, we need to know that the central angle is the angle that comes from the center of the circle, right? All three of these angles are central angles, okay? And that's important coming up, okay? So if this is 100 and this is 100, then this would have to be like 160 because all three of them add up to 360, 360 all the way around the circle. Okay, a lot of information here, but not, it's pretty basic, okay? Arcs are just part of a circle, right? A minor arc, see that red arc right there, and it's got the little arc over the top of AC. Okay, that's arc AC. Okay, that's less than 180, right? Okay, so anything less than 180 degrees is a minor arc. Okay, a major arc is something that's bigger than 180 degrees. Okay, so DFE, this red arc right here, is is a major arc because it's bigger than 180. As a matter of fact, it's 300, right? The measure of arc DFE is 300, okay? Remember, the central angle and the arc are equal, right? Okay, if that's 110, then that's 110, okay? We're not measuring this. We're only talking about the degree, the degree of the arc, okay? Uh, Later on, we'll be measuring and seeing how long AC is going to be, but not now. We're just talking about the degree measure. Okay, so this one right here is uh, is 300, right? Because it's 360 minus this 60. So arc ED is 60, and this one is 300, right? Okay, semicircles are half a circle, right? So 180 degrees for both of them. And something I didn't really talk about was that that if you have a major arc, then it has to have three letters for you to, know which way to go around, right? So if you say DE, that's this one, right? But DFE, you have to have that third letter for a major arc. And also for semicircles, okay? Semicircle, like this red arc and this blue arc are both 180 degrees. So if I don't put that third letter in there, then I don't know which way I'm going. I could say JL, but is it going the blue way or the red way? So you have to use three letters for 180 degrees as well. Okay? So arcs and central angles are equal. All right, so arg, okay, angle arg is 50 degrees, okay? So the measure of this arc is also 50 degrees, okay? The central angle and its intercepted arc, where it cuts through, this arc is the same, okay? So if, AB is a diameter because it goes through the center, right? So the measure of GRB, this angle, would be 130. Why? Because this is 180 degrees, right? Because it's a semicircle. So this is 180 degrees. So 180 minus the 50 would give me the 130 for this angle right here. Okay. So now what is arc GB? Okay, arc GB is this one. And remember that it's equal to the central angle. This central angle was 130, right? So this one is also 130. So this arc and this angle are the same size. Both of them are 130. Okay. All right. GSB is a large angle. Okay. Or arc, very large. Okay. So you go this way, all the way, GS, and then to B. So we know this part's 180, right? And then this part right here is 50 more. So you're going to get 230, right? 180 plus 50 is 230. Okay. BSA. Uh, BSA. Um, that's going to be 180, right? Okay, because it's half a circle. So that's 180 degrees. And then find the measure of TB. Okay. Well, this one's 50. So this one is also 50, right? Because they're vertical angles, right? Remember vertical angles? This is 50, and then this has to be 50. As a matter of fact, GA is 50 as well. So a bunch of 50s here, right? 50, 50, 50, and 50. Okay? All right, AB is a diameter, so how would you set up an equation here so we can solve for x? Well, all three of these add up to 180, right? Okay, so you could say 3x plus 30 plus 6x plus 10 plus 50, and then you set it equal to 180, right? And solve. Okay, so 9x, yeah, so x is just going to be 10. Okay, so y'all know how to solve that stuff. So let's move on. GA, okay, this arc right here, well, that's 50, right? Because the central angle is 50, its arc is 50 as well. And then GS, okay, if you know what x is, you can plug 10 in here. So 3 times 10 is 30, plus 30 more is 60. So that would be 60. All right. All right. Number 4, BSA. Okay. Well, BSA is 180, right? Okay. Because it's a semicircle. All right. Chords. Okay. We've talked about chords the other day. A chord is just it's a line segment that has endpoints on the circle, right? So ma is a chord. Okay. And then here's another theory, or if the chords are the same length, like PA and pa and he, if those two are congruent, then these arcs right here, arc PA and arc HE, are going to be the same size as well. Okay? Whoops, let me back up. Anyway, so if these segments are congruent, then the arcs are going to be congruent as well. Okay? Because it cuts off the same amount. Okay, 10.3 theorem. If you have a diameter that is perpendicular to a chord, then it bisects the chord. Okay, so HA is a chord, okay, that gets cut in half because the diameter is perpendicular to it. If it is, then this part right here and this part right here are congruent. Okay, so those two are equal, right? If this line and this line, if a diameter and a chord are perpendicular, then these two parts are congruent. As a matter of fact, this arc is congruent to this arc as well. Okay? And yeah, they're congruent as well. All right, so now let's go here to this. If I've got circle X and AH is this chord, which is 40, and then AE is this arc, which is 50, and then XP is this radius that's 25. Okay, so what is SA going to be? Okay, well, since it's perpendicular to the diameter of this chord, then it's going to be half of AH, which is 20. All right, and the arc AH, okay, this arc right here, AH, okay, this one says AE is 50, right? So if this one's 50, this one's got to be 50 as well. So AH is all the way around here, and that's 100. Okay, number 3, XH. Okay, XH, it doesn't have a line there, or a line segment, but that's a radius, isn't it? So wouldn't that be the same as this radius that we already have a number for? XP is 25, so XH is going to be 25, right? Okay, let me see, APH, where's APH? APH, oh, it's all the way around, is going to be equal to, remember this was 50 and 50 is 100, right? So if that's 100, then subtract from 360 and you get 260, right? For this big arc that goes all the way around to here. Okay, number 5, is arc AE equal to angle ASE? Is this angle, which we know is 90, equal to this and be 90 as well? Okay, they're not, because this is not a central angle. If it was a central angle, then the arc would be the same, but it's not a central angle. Okay, so that's a no. Number 6, the measure of AE, this one right here, is that equal to AXE? And that would be yes, because that central angle here would be equal to the arc that it cut off. Okay. Number 7, is XA equal to XE? Yeah, they're both radiuses or radii. So that's a yes. And then number 8 is the measure of angle PSA equal to 90. Angle PSA, yeah, that's a 90, sure. Okay. And is arc PA, this one right here, is this one 90? No, because it's not a central angle. If it had been on the central angle, like here, then we could have said that, but this is not a central angle. So you can't say that it's equal to 90. Okay? Next, okay, if two chords are congruent, in other words, Pa and MH, if they're congruent, then they're equidistant from the center. So this segment right here and this segment right here are going to be the same length. And that's if that chord and this chord are equal. Okay? So if those are equal, then the distance away from the center is equal. Okay? And here's a weird problem. Let's talk about this one. We want to find the radius. Okay? I don't see any radiuses ready to go, radii, but I'm going to figure this one out. Okay? That's going to be my radius. All right, but first of all, I need x. I need x. What's true about this and this? These two segments are congruent, right? Because Pa and MH are both 40, right? So if they're both 40, then these are going to be the same distance away from the center. So I can set these equal to each other. So I can solve for x. So set them equal to each other, subtract 3x from both sides, add 2 to both sides, divide by 2, and x is 3. Okay, so I can take 3 and plug it in right there. Okay, 3 times 3, okay, 3 times 3 plus 4 is 13. So this segment right here is 13. Okay, so I'm going to put 13 there. Now I also know that this whole length is 40, so this one's half, right, because that's perpendicular to it. So since it's perpendicular, it acts as a diameter being perpendicular to a chord, so this part's going to be 20, right? So I'm going to put 20 right there, and then now let's draw in the radius, because that's what we're trying to do in the first place, is find the radius. So all I have to do is find x. And since this is a right triangle, I can do the adding Pythagorean theorem, right? So let's do that. So the square root of 13 squared plus 20 squared is 23.9. And that's how you do it. And we're done. Yay. Okay. Let me see. I got to turn this thing off.